Hello people, so this is a continuation on my video on functions, and we're going to focus on periodical functions, so they repeat after a certain period. I chose the function sine of x, but a periodical function is cosine of x as well. With these functions, the core idea is that they repeat their values over a certain amount of time, you could say, or over a certain length. So here we see that our sine of x at 0 is 0, then it continues to pi, and from pi it continues to 2 pi. We can see that for every length of pi, the value of our sine function is going to be 0. So it repeats around the period of pi. We can multiply this by any whole number. So if we multiply it twice, we still get the same value. So whole numbers means like numbers like 1, 2, 3, minus 1, minus 2, and so on. We can repeat this process into infinity and still have the same value, which is very interesting. What we always notice as well, and what we must notice, is that at pi half our value is 1, whereas at 3/2 pi, which is about the length of pi, this is the length of this is pi, our value is the opposite value, it's -1. And so what we come to realize is that sine of x is actually a odd function. So there are also functions where we can't say that they're odd or even. So let's say we have a really peculiar function like 2x plus 1, or sort of any function that does not go through 0. Because if we have a function that goes through 0, we can kind of already tell visually that it's going to be odd. And if we have any function that has the same values of y for the same absolute values of x, I'll just write that down quickly. The f of x is the same then that's an even function. But what happens if it's not even, or if it's odd? Well, nothing really. All we mention is that the function is neither odd nor even. So it's not an odd function and it's not an even function. Another thing I have to mention also is the maxima and minima of functions. So we can have a local maximum, which means basically that it's not the highest point of the whole graph, but on a certain interval, let's say from 1 to 3, it is basically the highest point of our graph. Local minima, again, on a certain interval, it is the lowest point of our graph. Later on, once you learn derivatives, you'll know how to find these maxima and minima using different kinds of tricks. But let's have a look at some examples, shall we? So, if I have the function x squared, where do you think our local minimum is going to be on the whole function? Let's have a look where our local minimum is. It's around the point 0. As you can see, our graph goes through the point 0, and nowhere does it go below the point 0. Another thing I must state is that we write the local minima of a function based on where they are located on the x-axis, not the y-axis. So if I have a function which goes something like this, where this point, since it's filled in, means that it belongs to the function. This point, number 3, is the local maximum of our function. Now, if I just quickly scroll down, we have also global maxima and minima. These are over a given interval, so x has to belong to a given interval, let's say from 0 to 5, or let's say all real numbers. This has to be a subset of real numbers. It can't be from minus infinity to infinity. It has to be a subset of R. So let's say minus 7 to 8. It really depends on you which interval you choose, which is best for your function. So, as an example, we are going to find out the maximum of the function y equals x squared, because this is another interesting case, is when we don't have a local maximum. How do we find out we don't have it? Or how do we find out we do have it? So let's find out if it has a local minimum. If we plug in all the values, 0, 1, 2, and so forth, we sort of get a pattern emerging, and we realize that our function doesn't have a visible local maxima. It has a very visible local minima. Therefore, our function doesn't go below a certain point. So that must be our local minimum and goes through it. Now, if we have a local maximum, let's say y equals minus x squared, it's basically just like function upside down parabola. This point here, again our 0 point, is going to be our local maximum because there is no higher value than it. This is our maximum y value, and it's at the x point 0. We always mention it on where our x point is. So our local maximum is on the x-axis. Where is it located on the x-axis? It's located in the point 0. And our local minimum of our function y equals x squared